Welcome to our training on collaborative robotic automation. Today we'll be going over robotics, collaborative robotics automation, Cobot's Modbus TCP-based motion control, programming collaborative robots, some data communication used in cobots, robotics and other applications with Modbus RTU to Modbus TCP tiny gateways, and EtherCAT-based motion control. Robots are automated machines that help with specific tasks with little or no human intervention. Robotics is a field of study that combines engineering, science, and technology to make machines. Collaborative robots, or cobots, are industrial robots that safely work along with humans in automation applications. They usually have round edges and are designed for safety. They're usually lightweight and do repetitive tasks, while humans do tasks that take complex thought. Some large manufacturing systems use traditional industrial robots that are large and expensive, often used for high volume production processes. Smaller volume manufacturers often have flexible production systems where they can switch things around. Cobots are small, flexible, and can be used almost anywhere. They're easy to install with easy to use apps and software. They help with production safety and are used to implement monotonous and dangerous tasks so human workers can focus on more complex tasks while staying safe. I'm Maria Santella, sales manager here at ICP DAS USA. I've been with the company for 12 years, have a degree in computer science, and was previously an application engineer, technical sales engineer, and web developer here. I can help you use, market, sell, and provide you with support for our products. ICP DAS USA provides industrial automation equipment for monitoring and control applications. We provide low DC voltage equipment that supports a wide operating temperature. We manufacture our products in Taiwan and have an R&D department with over 100 engineers. We ship fast from Houston, Texas, carry a large inventory, and we ship out-of-stock items within about a week. We can ship on your UPS account or add the cost of shipping to your order. And we help with orders by a credit card, ACH payment, wire transfer, or you can apply for net 30-day terms. We also offer volume discounts and OEM pricing, and you can order through our e-commerce website, or we can help you with orders by phone at 346-292-9998, extension 1. Later in the training, Robert Murao, our senior technical application engineer, will be demonstrating AVEVA Edge SCADA software for monitoring motion controllers through most industrial protocols and how AVEVA Edge can be used in motion control applications like PackML and OEE. Please enter in your comments or questions. If you're working on any projects we can help with, please let us know. We provide a wide range of low DC voltage industrial control and monitoring equipment that operates in extreme environments. We also provide SCADA software. We provide programmable controllers, PLCs, data acquisition, gateways, protocol converters, wireless, PC boards, touchscreen controllers, data loggers, Ethernet switches, and more. We help answer questions, troubleshoot issues, and provide programming services as needed. We provide a 1-year warranty, free data logging, control, and monitoring software. We also provide training classes that can be catered around specific projects and applications, so your project could be completed while training on how to implement it. Collaborative robots, or cobots, or service robots, are industrial robots that safely assist people with automation applications. They usually have round edges, are designed for safety, they're lightweight, they do repetitive tasks. Collaborative robots, they transport materials around buildings, help people move heavy equipment, assist in product assembly, and they're used in manufacturing, agriculture, medical, pharmaceutical, packaging, welding, inspections, quality assurance, food and beverage, chemicals, plastic, metals, and more. Cobots usually involve I/O interfaces, grippers, vision systems, vacuum tools, sensors, SCADA software, and touchscreen controllers. SCADA software and voice commands are often used to control cobots. Motion controllers allow for the movement of the arm and other collaborative components. I/O interfaces are used with sensors for determining proximity of objects and people nearby. We provide data acquisition equipment communicable over many protocols, including EtherCAT, Ethernet IP, Modbus RTU, Modbus TCP, Profibus, and more, with I/O types including thermocouple, RTD, thermistor, current, voltage, analog, digital relay, and more. Grippers and vacuum tools are used for picking up and handling items, and vision systems allow for visual-based processing, analysis, and decision-making. I/O interfaces are used to control the grippers and the vacuum tools. Cobot control is usually done with a touchscreen device running SCADA program that allows for selecting tasks and functions like the starting of a process for the assembly of a machine, or welding parts together, drilling screws, removing materials, sanding, and polishing. We provide programmable touchscreen controllers, SCADA packs with touchscreens on board, and SCADA development and runtime licenses for use on embedded systems and computers. AVEVA Edge SCADA software is being used for interfacing with cobots through a graphical user interface for motion control applications. It connects to control and I/O equipment over software drivers and supports different operating systems. Servo, linear, and stepper motors are often used in cobots for pick and place and material handling functions. Accurate phase current sensing helps with proper torque and efficiency, battery management systems, and general peripheral monitoring. We provide power meters with clip-on current transformers and also current input boards. Collaborative robots often have 6-axis motion control modules that communicate over Modbus TCP or Ethernet, like ET-M8196F, which is often used to replace PCI-based motion control cards. ET-M8196F has 2 Ethernet ports and supports daisy chain Ethernet wiring. It has a digital signal processor for calculating movement trajectory, limits, and emergency stops, ensuring safe operation. I/O control output, including latching, comparing, encoders, counters, it's done over a field programmable gate array. Programming collaborative robots includes creating instructions and code to control the robot's movements, tasks, and other interactions with its environment. Since collaborative robots are designed to work alongside humans, their programming typically focuses on ease of use, safety, and flexibility. We provide an API for communicating with ET-M8196F with motion control functions, including 6 linear interpolation, 2 or 3-axis circular interpolation, helical interpolation, TS curve acceleration and deceleration, and automatic home search. Software development kits and demo programs are provided for use with LabVIEW, .NET, Visual Basic, Visual C++, and Borland C++ Builder. We also provide Modbus register mapping tables for easy use with SCADA and other software. Our Easy Move utility software application is provided, which allows for easy Ethernet configuration, motion settings, and control. With Easy Move utility, you can edit and run macros, set parameters, and C, the Modbus communication data format. In Modbus TCP networks, M8196F acts as a server for Modbus TCP networks. A computer, PLC, HMI, or PAC Modbus TCP master accesses remote motion controllers over Ethernet cabling. The manual we provide with ET-M8196F, it has information on the Modbus register mapping tables for the variables, axes, the address, and the read and write access. There's also Modbus registers for the stop status, logic position, encoder position, current velocity, and current acceleration that you can easily use in your applications. Demo programs we provide establish connection and communication with equipment, have timer initialization and use of timers for wait and timing functions. There's also examples of get and set position information, running macros, controlling movements, stop functions, and more. Our TGW-700 Series tiny gateways convert Modbus RTU to Modbus TCP. You can use multiple Modbus TCP masters with your Modbus RTU slave devices, use multiple COM ports. You can also make serial Modbus RTU tunnels over Ethernet cabling if you use two TGW-700 series tiny gateways connected with an Ethernet cable. These can be powered over Ethernet or powered with 12 to 48 VDC. EMP-2848M is a compact EtherCAT master soft PLC PAC controller with a real-time Linux operating system that can run WinGraph, IEC 61131-3 programs written in function block diagram, ladder diagram, instruction list, structured text, and sequential function chart. EMP-2848M can control up to 128 EtherCAT slaves and supports up to 16-axis motion control. It comes with drivers and is being used with other vendors' equipment. We also provide EtherCAT junction slave modules that support daisy chain, star, and branch topologies. We also provide EtherCAT I/O modules, EtherCAT stepper motor controllers, and EtherCAT to Modbus gateways. Now I'm going to be passing it over to Robert Murao, who will be demonstrating AVEVA Edge SCADA software monitoring motion controllers.
Today, I'm going to go into a few details about our ET-M8914H. This is a long-standing product that has been out in the market for, I'd say, about 8 to 10 years. Let's see, it's one of our older products in the motion control, but it's also one of our most popular products. It's a Modbus TCP-based 4-axis motion control module. We have another module which can go up to 6 axes, so if you do have applications larger, you can use either that one or multiple ones of these. It's very easy to use. As Maria mentioned in her presentation, our EasyMove software is used to create motion profiles and motion diagrams for this. Let's see, I'm going to go over a brief application diagram here. So the ET-8194H is shown here in the middle. Let's see, we have a wiring terminal board, actually a few different versions for different wire configurations, but the DN8468 just simply connects your servo or stepper motors to the ET module. The encoders are also wired into this board, so as the encoders, or I'm sorry, as the servos move in one direction or the other, the encoder movements will be counted, and the motion controller will know where the position of the servo motors are. Once you program the positions in, you can control them using a PLC, a programmable automation controller, or a SCADA software as shown here in this picture. The one that we're going to show you later is called AVEVA Edge. It was formerly Indosoft, but the new name is AVEVA Edge, and it can communicate by Modbus TCP. We do have newer models which can also do EtherCAT. It's just a different motion control module, but it's the same exact idea. This one here communicates Modbus TCP, so when your PLC or your SCADA software or your PAC determine which position you want to go to, it communicates to the motion controller, and the motion controller starts the specific motors to move to the certain positions. You can also program in coordinated movement for like 2, 3, 4 axis, 5 and 6 axis coordinated motion. Let me go here. This is a close-up of the module itself. This is the connector where you connect the daughter board to. And let's see, this is a close-up of the daughter board. It's a little fuzzy because the image is blown up, but you can see it has many different terminals. I think I have, yeah, here's the actual pin assignments here. It's got your encoder connections for all your axes. It's got your in-position signals, alarm signals for, what do you call it, for going past limits, limit switches if you have them, and inputs for the axes. These would be for like monitoring stops and limits that you want to move to. Let's see, when we go to the motion control daughter board, this is then wired to this using a SCSI cable, which we sell in many different lengths. I think, let's see, a 1.5, 3, and 5 meter version. You can use a standard SCSI cable that you can purchase yourself with the length that you want, or you can use one of ours. They do not come with the module because so many different customers have different applications where the length can vary greatly for applications, so we no longer include the cable, but you can purchase them as an accessory, or you can use just a standard SCSI cable purchased outside. Okay, now I'm going to show you a few applications which you can use with either cobots or our motion control modules. This is AVEVA Edge. AVEVA Edge is a full-blown SCADA package where SCADA stands for supervisory control and data acquisition. So from the supervisory control aspect, you can use the recipes to execute a certain recipe, meaning like say you are a small manufacturer, you may do small, medium, and large packaging, for instance. You know, when you set the SCADA software to do small, it'll dispense certain amounts of liquid or solids into maybe a container. The container will move along conveyor controlled by one of our motion controllers. Then the cobot will, you know, maybe pick and place the bag or the object off the conveyor, or, you know, various other applications. But with this software package, you can use the animation and the various other features of this to create a nice visual interpretation of your project, or you can create a more of a control panel aspect. And there's also a few other applications which I'll show you at the end, which AVEVA Edge is great for. So using the animation, you can, you know, show the operator visually where everything is along the line. Like for instance, you could use color changing to show that either the object is in place, the robot is ready to go, or what do you call it, position as well. You could use the numerical numbers shown here to maybe show physical counts of how many packages have been processed or how many parts have been made. Using the solutions shown here, the AVEVA Edge software is great for PackML applications, where you can just monitor where the cobots or the processes within the application. You can make sure everything is either started, stopped, or on hold or paused. For overall equipment efficiency, it's also great. So you can monitor performance of your equipment, availability of raw products, and the quality of the merchandise or products produced. You can monitor machine uptime and downtime, monitor speed of process, availability, all these different variables that can be measured using sensors and logic from either our data acquisition modules or from the motion controllers. You could also create just a simple control panel operation, which I think we have one here. Let's see, where was it? Oh, here we go. Control panel, where you just create your stop and start button. Maybe you have a few other buttons besides manual and auto that just say small, medium, and large. So what'll happen is the pre-programmed recipe that you create for the SCADA process, you set the process type, whether it be small, medium, or large, then you press start. The conveyors may move the product in place, dispense the liquid, solid, or whatever you're wanting to do in your application, and then execute the process. And once the process is complete, move on to the next item. And you could create multiple screens with this. So maybe from this screen you could start the process, but then you could switch over to something like the overall equipment efficiency screen or something similar, where you could just monitor production and control and create reports as well.
Thank you so much for attending, and then hope you have happy holidays.
Everyone have a Merry Christmas and great New Year. We'll see you next year for our next presentation.
Thank you.
Okay. Bye-bye all.